I'll be explaining binary representation to you. It's used a lot in implementing algorithms. Normally we use decimal representation. Um, decimal representation In decimal representation we use the digits from 0 to 9 inclusive, so there are 10 possibilities for each digit, and the rightmost digit represents 10 power 0, the second rightmost digit represents 10 power 1, the third rightmost digit represents 10 power 2, and so on. And the overall value of a representation is rightmost digit multiplied by 10 power 0 plus second rightmost digit multiplied by 10 power 1 and plus third rightmost digit multiplied by 10 power 2, and so on. Similarly, in case of binary representation, we use only the digits 0 and 1 to represent any number, and the rightmost digit represents 2 power 0, the second rightmost digit represents 2 power 1, the third rightmost digit represents 2 power 2, and so on. And the overall value of a number or a binary representation is rightmost digit multiplied by 2 power 0 plus second rightmost digit multiplied by 2 power 1 plus third rightmost digit multiplied by 2 power 2, and so on. Now let's understand the left shift operator. The left shift operator shifts the bits of the left operand by right operand number of times to the left. For example, if we take 3 left shift 2, so the binary representation of 3 is 1 1, and when we left shift it twice, we add 2 trailing zeros to the right. Now if we calculate the value of this representation, we have 0 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 1 into 2 power 3. So we have 4 plus 8 equal to 12. We can observe that it actually multiplies the left operand by 2 power right operand times. Now let's see right shift operator. The right shift operator shifts the bits of the left operand by right operand number of times to the right. So if we consider 8 right shift 3, the binary representation of 8 is 1 000, and after shifting it 3 times to the right, we remove the last rightmost 3 digits, so we are left with 1. The decimal value of the binary representation 1 is also 1. So 1 into 2 power 0, which is 1. We observe that when we right shift a number, we actually divide the left operand by 2 power right operand and return the quotient. Now let's see the AND operator. The AND operator does the bitwise AND of the left operand and the right operand. So for instance, let's consider 3 and 6. The binary representation of 3 is 1 1, and the binary representation of 6 is 1 1 0. To make the number of digits same, we can add leading zeros to 3. Let's consider rightmost digits. Both have different values. One is 1 and other is 0. So the AND is 0. And let's consider the second digit. Both are 1, so the AND is 1. And the third rightmost digit, we have 1 1 and 1 0, so the AND is 0. So the AND of the two numbers 3 and 6, its binary representation is 1 0, and if we want to find its decimal value, it's 0 into 2 power 0 plus 1 into 2 power 1, which is 2. Now let's see OR operator. The OR operator does bitwise OR of the left operand and the right operand. So let's consider 2 or 6. The binary representation of 6 is 1 1 0. The binary representation of 2 is 1 0. In order to make the number of digits equal, we can add a leading 0. Now the binary representation of the OR of these two numbers will be the bitwise OR. So the rightmost bit in both the cases is 0, so it will be 0 in the result as well. The second rightmost bit in both the cases is 1, so it will be 1 in the result, and the third rightmost is 1 in the case of 6 and 0 in the case of 2. So the OR of 0 and 1 is 1. So in the result, the um, the third rightmost digit will also be 1. So the result of OR is 110, and its binary and its decimal value is 0 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2, which is 4 plus 2, which is 6. Now let's see XOR operator. The XOR operator does bitwise XOR of the left operand and the right operand. Now let's see 2 XOR 6. The binary representation of 2 is 10 and the binary representation of 6 is 110. We can add a leading 0 to make the number of digits same, and then let's consider the rightmost digit in both the binary representations. Since both are 0, so we'll make it 0. And let's consider the second rightmost digit. Both are 1, so we'll again make it 0. Let's see the third rightmost digit. It's 0 in 2's case and 1 in 6's case. So it's the XOR of these two values will be 1. So the overall XOR will be 4. Hope you understand this. You can read further about these in you can read further about these concepts if you